All right, ladies and gentlemen, assignment 2. This will close out our work with functions. Basically, what we're going to do here is we're going to find the opposite, the inverse. That's all that means. Inverse means opposite of the function. All right. One thing to keep in mind, the function, so for example, our function f of x equals 3x minus 2. Once we find the inverse, we're going to write it no longer as f of x. We want to be able to tell the difference between them, and we want to indicate that it is the opposite. So your f of x becomes f of negative 1 of x. That negative 1 just, you don't even read it like that. You just say the inverse of f of x. So this is f of x. This is the inverse of f of x. We just write it like with a negative 1 to show that. Okay. So first things first with inverses. Think of a function like a machine. All right. Here is a table for our original f of x. And you can see for x, we just picked some numbers, negative 1, negative 2, negative 1, 0, 1, 2, 3. Those are numbers we picked. And when we plug it in to the machine, negative 8 is what comes back. Look, negative 2 times 3 is negative 6, minus 2, negative 8. Negative 1 times 3, negative 3 minus 2 is negative 5. Plug in a 0, you get negative 2. Plug in a 1. So first thing I'm going to want you to do is finish the table. If we plug in a 2, 6 minus 2, 4. And then 3 times 3 is 9, minus 2, 7. And so you can see you're going up by 3 every time. And remember, look, negative 2, there's our y-intercept, and the slope is going up by 3 every time. Now, that's our original function. Now, we're not even going to find the inverse for this one. But what you can say is think of if it's a machine, and in our original function, you have your inputs, you plug them in, you get your outputs. It's going to be the opposite. It's just going to undo what we did. So here, we're going to plug in a negative 8, we get a negative 2. It just flip-flops the x into the y. So you're just going to go through and make sure to flip-flop. It undoes. So if we plug in a negative 2 into the inverse, we should get back a 0. It'll undo what we did. If we plug in a 1, whoops, get a 1. If we plug in a 4, get a 2. If we plug in a 7, 3. So first thing to note is the inverse just it undoes what the function did. So if we plug in a negative 2 and get a negative 8, it just undoes it by doing the opposite. We flip-flop the x and the y. So that's really important just to know. You are going to have to do that first thing using a different function there. All right. Now, how do we actually find the inverse? I'm going to be flipping over here in a second. These notes are the same as what you have in your worksheet. There are steps, all right? And we're going to follow those steps. I'll read them briefly, and then I think it'll be easier for you to understand what's going on. So it says, replace the f of x with y. Remember, f of x is the same as y. The f is the name, the x is what we're plugging in. But in the end, when we have something set up like this, g is the name, x is what we plug in, you can replace it with a y. And that makes it easier for us, less going on. So that's step number 1. Step 2, reverse the x and the y. Just like we did, right? You're just flipping the x and the y to find the inverse. This is a way to do it mathematically. Solve for y and replace the y with our f of negative 1 to the x. Now, let's actually do it. Okay, now I already have my work plugged in here. You do need pictures of your work for this one, but here we go. Step 1, replace g of x with, so this is our original. This is the function. That's the original. And at the end, we will have the inverse. I'll put an arrow and we'll say inverse. So here we go. Step 1. Replace g of x with y. Looks like y equals mx plus b. And that is exactly what this is. This is a linear function. G is just the name of the function, but we can replace it with y. That's step 1, right? Yep. Step 2, reverse the x and the y. And so what you're going to do is I'll do it in a different color here. X equals, oops, come on. It's supposed to be a different color. y plus 2. So just to reiterate, step 1 was rewrite it as y, and then step 2 is flip it. Would be to flip it. All right. Step 3 is going to be solve for y. So check where y is. Y is now on the other side, and we need to get it by itself. We need to solve to get this one by itself. What are we going to do? We're going to undo 2, subtract 2 from both sides. You get y is equal to x minus 2. And you're basically done. You got the y, solve for y. You got the y by itself. So all you have to do then is now I like to change the order like this. So g, negative 1 of x equals x minus 2. The final step is you need to replace the y with the function name. It's called g. Let's make sure it's g. But the negative 1 indicates that this is the inverse. That is your answer, right? And so think about it. If I pick the number 1, right, and I plug it into the original, right, 1 plus 2 equals 3. So the answer I got was 3. The inverse is if I plug in 3, you get 1. It undoes what we did. So think about it. If we added 2, that's our original function, the inverse should subtract 2. So it's pretty easy to see there. So this is the inverse. Now it's going to get a little bit more complex, but I think as long as you understand those, do it step by step. Reference those steps. For the next one, here is our original function. First, step 1, replace the f of x with y. All right, that's step 1. Step 2, switch the x and the y. X goes here, y goes there, and you flipped it. Now we need to solve for this. We need to get this by itself. How are we going to do that? We're going to undo everything around it. Add 5 to both sides. All right. Still need to get this by itself. Divide both sides by 2. Now, you don't have to do anything like fancy here. The answer is y x plus 5 over 2. Don't try and divide x by 2. It's impossible. No reason to do any division. You're done. Just make sure the function is called f. So f of 1. So the inverse of f is x plus 5 over 2. There it is. That's your inverse. That's your answer. All right. Same thing. Step 1. Replace the g of x with y. Switch the x and the y. We need to get y by itself. So solve for the y. Step 3. You'll add 1 to both sides. You need to get this by itself. So we want to move everything else over. Now, we get here. You could divide by 1/5. I saw a lot of mistakes last week where people were doing something very strange, but with something like this. But it doesn't matter. Either way, 1/5, to get rid of it, in this case, it's going to be easiest to multiply by 5. 5 times 1/5 is 1. Now, I like to put the 5 on both sides so you know that you're multiplying. And so the 1/5 cancels with this here. It's a different color, and then it distributes to each. 5x plus 5 equals y. And you're pretty much done at that point. The function was called g again, so call it, so you say g, so the inverse of g is 5x plus 5. That is it. So to undo a fraction, just multiply what's in the bottom of the fraction, basically. We'll say that one more time in the last example. All right, same thing. Replace the h of x with y. There's a fraction here. Don't worry about it for right now. Switch it up. X is 3, y plus 5, 4. All right, so I'm going to slow down just for a second. And we want to solve for y. We want to get this by itself. In order to do that, first we need to get rid of that -4 on the bottom. When I say to get rid of a fraction, you want to multiply by the denominator. You're going to multiply by -4 to both sides. That cancels it because this -4 is on top, right? It's on top. We can write it as over 1. If you have something on top and bottom, they cancel. So you got -4x equals 3y plus 5. We still need to get the y by itself. From here, it should be a little bit easier, hopefully. Subtract 5 from both sides. That gets rid of that on that side. And then divide both sides by 3. And that's pretty much it. You just need to, it was called h this time. So your answer is, like I said, I like to change the order and put this on this side. And that's basically going to be it. That is how you find the inverse, the opposite of a function. And that'd be it.